It's on YouTube. It's a live stream. So just make sure I turn off the live stream because yesterday I forgot to turn off. Yes. Huh? You fix your voice thing? I think so. They can hear my voice, right? Yeah. I don't know. Fabian, you're my tech. Okay. I need a tech aura. You're gonna sit right next to me. You're gonna have to replace a bit. You're replacing a bit. What? I'm hopping on the stream. Are you hopping on the stream? Okay. Chat, can you hear what I say? Chat. Chat, is this real? Real. All right. So all right, we're gonna go through all the formula sheet. You're supposed to know that formula sheet, but I'm gonna go through in detail. And I'm gonna go through in a very, very detail because this is an easy grade for me. This is a very easy grade. But for me, like you have to know all the connections. I like to tell people that there's connection between each formula that you're supposed to know. Okay, so if you know your math, that sine theta is equal to 1 over cosecant theta, and this is 1 over sine theta. This is reciprocal identity. 1 over secant theta, and the 1 over cosine theta, and the 1 over cotangent theta, and the 1 over tangent theta. This is called reciprocal identity. And there is a reason for that because in your normally scientific calculator, it doesn't have a cotangent button. So you're going to have to get your value and then use reciprocal identity to figure out. So for example, the cotangent of 30 degrees, without decimals, if you just use scientific calculator, get your scientific or your cell phone calculator come out, it doesn't have a cotangent button. So what happened? You have to do 1 over tangent of 30 degrees. Okay. Also, on the fact that those people do SAT, yesterday I was helping my son with, not my son, a group of students. I tutor SAT outside. And one of the SAT question was tangent of 92 pi over 3. So do you know the answer of tangent of 92 pi over 3? Raise your hand if you do. Separate. I bet you're going to get a wrong answer. Fine. Okay. $20. 20 bucks? Yeah. I'll pay you $1. General best. I'm on teacher salary. Huh? Where were the 3? You lost $1. You lost $1. You lost $1. You lost $1. Okay, $1. Take it off of your paycheck. No. I have those testing paycheck, Mr. M. I grade like 10 tests. See, you're always so like you're the problem with you is you don't have a I don't know state. You don't have a today. You're gonna fail. So tangent of 92 pi over 3, basically knowing that it's going through like a cycles, and it's gonna go through like I don't know 15 cycles, because each cycle is 6 pi over 3, so 15 cycle is gonna get to 90 pi over 3. So you got 2 pi over 3 left. So same thing as tangent of 2 pi over 3. But end up you could actually get an answer from here. And that's why I told all the people on SAT, if you don't remember, just type in tangent 2 pi over 3. But you want to make sure that this in radian or degree, because if you type in degree, you're going to get a wrong answer. Radian will give you a right answer. So you got to make sure you know your decimal, radian and degrees. You can change that. So in case that the SAT preps that you don't remember what is that value, or you want to make sure the value is right, then you can go through that. Winston, what are you watching? Your stream. Okay, move your seat so you can see the front. All right, tangent is sine theta over cosine theta. Is that okay? Cosine theta over sine theta. Is that okay? All right, so that's good. So we're going to talk about Pythagorean identity. Pythagorean identity start with the geometry. So geometry is going to be here. As a squared plus b squared equal to c squared with a right triangle with theta. You don't need to know this proof, but I'm going to show it to you anyway. A, B, and C is like this. A is known as opposite, and B is known adjacent, and this is the hypotenuse. So if you take the geometry and you divide it by C, so that's going to A over C squared plus B over C squared is equal to 1. Is that okay? What's A over C? Also known as opposite over hypotenuse, right? And adjacent over hypotenuse, right? And what's opposite over hypotenuse? Sine theta squared plus cosine squared theta is equal to 1. So they come up with the first identity of sine square of theta plus cosine square of theta is equal to 1. Now, square, make sure they are small. You cannot write down sine 2 theta plus cosine 2 theta. Sometimes people on the test, they write down that. That's wrong. You got to make sure that square is square. Any question about this part? Do you know, did anybody remember how to devise the other two Pythagorean? How to get the other two Pythagorean?
Divide by sine, cosine.
Okay, divided by sine. So we're going to take these functions, right? We're going to take them down like here, and we're going to say, well, this is sine squared theta plus cosine squared theta equal to 1. I can divide it by cosine. And if I divide it by cosine squared theta, that's going to be 10 squared theta plus 1 equal to secant squared theta. This is also one thing you need to know. Like that's how you get to the other Pythagorean identity. And I can take this function again. I'm going to take the sine square plus cosine square. And I'm going to, instead of divided by cosine, I'm going to divide it by what? Sine squared theta, though. So that's equal to 1 plus secant squared theta is equal to, no, that's not secant. This one's cotangent squared theta is equal to cosecant squared theta. Thank you. So you know half the formula already. Let's know the other half. In pre-calc, sine of A plus B, sine of A minus B, sine of A plus B, sine of A minus B. The easy way to remember this is the acronym S, M, S, or C, S, O. So this is for this, and this is for this. This is sine, this is cosine. This is a mixed group. This is the same group. And this is the same sign. And this is the opposite sign. Okay. So what do I mean by that? That means I can group them in a certain way, and they are in a special arrangement. Now, I cannot have a time enough to prove you some indifference. I need a whole period to prove it. Not even in AP pre-calc, I will prove it because it takes longer to prove. But if you're interested about proof, you can go up on YouTube, just say proof of some indifference formula. They come up very, very interesting math. And but that's beyond the scale here because most of the students just need to know the formula. So on that purpose, we're going to talk about how to remember sine, mixed group, same sign. Mixed group is the way you have to mix it is going to do sine and then cosine and then cosine and sine. And then if you, this is a plus, this is same signs plus. And just fill in the A, B like this. And make sure they switch the order. So cosine, sine. And that's how you get wonderful. Same thing as the other one. I'm going to write down the mixed group. Is mixed between sine and cosine and sine. And this is a minus. And that's going to be A, B, A, B. And this is the sum and difference formula. cosine of A plus B. This one is going to be cosine. So it's the same group. What do you mean by same group? The same group is going to be cosine, cosine, sine, sine, because they're just grouped together. And you still write down AB, AB. The only thing you have to pay attention, this plus sign is going to be opposite signs now. So it's a start with plus and or negative.
Negative.
Yeah, negative. And I'm going to write down cosine, cosine again. And sine, sine. And I'm going to write down AB, AB. And there's a plus sign. Yes.
How does it make any difference? Oh wait, no. I figured it out. Well, that sounds good.
Good. Sine 2 theta. This one is you're supposed to memorize. How many of you guys memorize? Raise your hand if you memorize sine 2 theta. Jacob? Oh, Jacob memorized. What is it?
2 sine cosine.
2 sine theta, cosine theta. You must have an argument. The theta is called argument. You cannot ignore them. You cannot just write down two. If you write down on the test 2 sine theta, 2 sine cosine, I cannot give you credit. But if you write down 2 sine theta, cosine theta, because if you type in nothing in the decimals, it's gonna give you infinite value. If you have to give it value, the value is the argument, and you have to understand the argument. Now, here's the thing: how do you get that? Like some of you guys know how to get that, right? The way kind of think about it, use this formula here, and I'm gonna write down the side. And just imagine that if you have sine 2 theta is equal to sine of theta plus theta, and then I'm going to use this formula to get it. So that's equal to sine, cosine, cosine, sine. And this is A, this is B, and this is A, and this is B, and the plus sign. Do you see those two? It's just a different order. So they are the same thing. So that's equal to 2 sine theta, cosine theta. Is that okay? Because they're the same. The theta is even the same. You can do the same thing with cosine 2 theta. Is equal to cosine of theta plus theta. So that's equal to cosine theta minus sine theta. Sorry. Sine theta. So that's equal to cosine square theta minus 1 minus sine square theta. So that's equal to cosine square theta minus sine square theta. Do you see the connections? Now there's two other versions of cosine 2 theta. How do you get the other one? Pythagorean identity. Remember this? The blue one? The blue one is my favorite one because if you know this blue one, you can say sine squared theta is equal to 1 minus cosine squared theta, and the cosine squared theta is equal to 1 minus sine squared theta. This is a useful conversion. Convert from sine square to cosine square. So I can replace those things and replace it here. So do you see this? I'm going to replace that cosine square. What is cosine square? 1 minus sine squared theta minus sine squared theta. And that's equal. So this just completely replaced, right? I put a parenthesis so that way you know it's replacing. So 1 minus 2 sine squared theta. Is that okay? And this one is, instead of replacing this one, I'm going to replace this one here. So maybe replace here. So I'm going to keep the cosine square the same. And I'm going to replace that. So it'll be 1 minus cosine squared theta. So it'll be 2 cosine squared theta minus 1. If you distribute it, 2 negative sign becomes positive. The negative one's going to distribute because this negative sign distribute to both. And that's going to give you that. Any question in this part? Sine squared theta and cosine squared theta. Please do ask me a question because I don't have nobody asking question. I don't know if you intimidate by me, but you should ask question. Yes.
Why do we only remember A?
Remember A? Because the other one you can prove it. The other one you can prove it, and the A is most often used. That's the one that used more than the other one.
Okay.
Cosine square is used kind of. Cosine 2 theta doesn't use as often, but sine square is going to use pretty often. Okay. Sine square theta, and cosine square theta. Here's the thing. If you look at this particular question, sine square theta, you're actually, so this is equal to, by the way, this is equal to cosine 2 theta, and this is equal to cosine 2 theta. This is actually from there, believe it or not. You see here, and see here. If you evaluate for that, you're going to get this one. So imagine this. I'm going to write on this side. I'm going to prove this one, okay? So it'll be 2 cosine squared theta minus 1 equal to cosine 2 theta. Can I move the 1 over? So it'll be 2 cosine squared theta equal to 1 plus cosine 2 theta. And now divided by 2. And that's equal to cosine squared theta equal to 1 plus cosine of 2 theta over 2. And this becomes the, now it's not square, right? It's not square. And for the other one is a 1 minus 2 sine squared theta is equal to cosine 2 theta. Remember, we're trying to isolate this. And this is a good SAT question, just isolate a variable. I'm gonna move it to the other side first. 1 equal to cosine of 2 theta plus 2 sine squared theta. I'll move this over, so it'll be 1 minus cosine of 2 theta equal to 2 sine squared theta. And I'll divide by 2 on both sides. So it'll be 1 minus cosine of 2 theta over 2. And there you go. This, all the formula you will use for calculus. Well, at least Calc 1 or Calc 2. Yes.
Can you explain how we notice that it is 2 sine of theta?
Say that again?
Can you explain how we notice that it equal to 2 sine of theta?
2 sine of theta. For sine squared theta?
Yeah.
Because you're trying to evaluate for this. So you're trying to focus on this particular part of it and just move everything to the other side. How would that answer your question? I don't think I did.
No. Okay. I'll just memorize the formula.
Yeah. For now, I'm gonna, if I have time, I'll go more. Today I have to go a lot more stuff, so I'm gonna move on. But I appreciate that question. That question's probably good, but I need to think about it. You can ask me after class. Any question about this? Yes.
Let's zoom in on what sine squared theta was.
Now again, everything is on live stream. So it's www.youtube.com DJYUF. Okay. Subscribe, click like, and comment. Click on the notification button. Yes.
The answers to sine squared theta and cosine squared theta is with cosine 2 of theta, not squaring.
Yeah, they are 2. They are not square. Some people, they think it's square is 2. I write it slightly bigger. You got it? Okay, good. Your homework is on this one. It's on inverse trig. I already posted on the group chat. Did anybody see it?
Yeah.
Okay, so we're gonna start going over some. Basically, we are just going through a crash course of pre-calculus. We just go in really fast speed. Start with the sine inverse. Let's start with sine inverse. How many of you guys know what a sine inverse of negative half if you know what the sine inverse of negative half is. So 3 student. Lyndon's probably another one. Let me ask some people. Kaden, do you know?
I don't.
Oh, you don't? Okay. Jacob, do you know?
Well, I just want to ask, it's never going to be in quadrant 3, right?
You have a good point. So Jacob is really smart. He's asking the right questions because it's never quadrant 3. It's not only that, it's going to be between only this 2 quadrant of sine inverse. And not only that, tan inverse have the same quadrant, it's that it doesn't including y-axis. But sine inverse is including y-axis. So this is a pi over 2 and this is negative pi over 2. Inside the unit circle, it can only give you those values. Okay. And not only you cannot go to quadrant 3, you cannot pass the y-axis. You cannot pass the y-axis. Yes.
So then cosine is only above the x-axis?
Good. It's the top 2 quadrant, which is 0 to pi. Yes.
Can I answer the question? I think
Okay, what'd you get?
would it be negative pi over 6?
Negative pi over 6 is correct.
Yeah, you can't go completely around.
Now, how many of you guys are thinking 11 pi over 6? Raise your hand if you think 11 pi over 6. Don't tell me.
I wouldn't know.
Huh?
You can't go around. Can't.
Okay. So this is 1/2, right? This is negative 1/2. So you want to go here. It's 11 pi over 6. You are not wrong. You are not wrong about the fact. But sine inverse has a restriction. The restriction is this line right here. So this line is like an electric fence that you cannot get past. So you go here, you're gonna get zapped once. You're gonna come here, you're gonna get zapped another time, and eventually get here. Then you can say, well, why would I want to get zapped? I can just go down here. I can get the value I want, and that's going to be negative pi over 6. Does that make sense?
Yeah.
And the way to think about it is like, I'm going to ask you to go to California, and you can say, okay, I can swim through Atlantic Ocean and swim through Pacific Ocean and come to California. But you could have walked to California faster than you swim across 2 ocean. Besides, you're not going to survive. Is that okay? Okay. So can you tell me what is this question? Write down what do you think the answer of this one, and don't shout it because this is one of your homework question. Don't shout your answer. I'll call you. Sophia, what are you doing? No. Lee?
Negative pi over 4.
Negative pi over 4. Good. Okay, so it's negative pi over 4. Does that make sense? It's basically asking if the y value is negative square root of 2, what will be the radius inside the restriction, right? So you have to think about all those conditions inside your head, and you cannot make a mistake. Is this okay? Now, don't worry about h because h is undefined, and some of you guys don't know why it's undefined because pi is 3.14, 3.514 is over 2, is greater than 1. So you cannot have cosine inverse of value greater than 1 because your cosine graph is shifting between -1 and +1. You cannot go to above 1. Okay, so this is undefined. You don't have to worry about that question, and you don't have to worry about this 2 questions. This 2 questions for advanced students who can figure out. Those are the harder one. You don't have to worry about it. I won't put it on the test. But let's start with this question. Let's see how many of you guys can answer this one. C, 2C. Secant of tan inverse of -3 over 3. All right. Let's see. I don't want to. I know you know. Most of my students should be able to get this one pretty easy. I'm gonna ask the people is not my student last year. Max?
-2.
-2. I don't think so. Good try. Fabian. Leah?
I don't have it.
Oliver. I never call you.
-2 radical 3 over 3.
Let's check with Winston.
Just 2 square root 3 over 3.
The positive. Yeah. Okay, 10 inverse of square root 3 over 3 is going to be right here. And square root 3 over 3. Remember, you know 3 value. Tangent of pi over 6 is equal to square root 3 over 3, which is that's one that's going to help you. Tangent of pi over 4 is equal to 1. Tangent of pi over 3 is equal to square root 3. Now, cotangent is inverted. So, therefore, it has to be right here. So, that has to be secant of pi over 6 negative. Now, that's equal to 1 over cosine of negative pi over 6. And that's equal to square root 3 over 2 positive. So, it'll be 2 over square root 3. Winston, so 2 square root 3 over 3. So 2 square root of 3 over 3. Don't worry, separate from your off too. Next one. All right. Next one. Let's give you a C. That's an easy one. Start from inside, work to your outside. All right, what you guys get?
Negative pi over 3.
Negative pi over 3 is right. Is this okay? Good, Jacob?
I got negative pi over 6, but
Well, what is sine of 4 pi over 3?
sine of 4 pi over 3 is it's probably only like a negative 1/2.
Is a pi over 3 is more closer to y-axis. So it's actually square root 3 over 2. Pi over 3 is more closer to y-axis. So it has
4 pi over 3 was in quadrant 3.
yeah, it is quadrant 3, but it's more closer to y-axis. is 4 pi over 3 is right here, right? So it's more closer to y-axis. It has a longer y, shorter x. So it has to be square root 3 over 2 negative because it's longer y. And if you match it to the other side, that's how you get that answer. Is that okay? All right, so I'm going to answer those questions here. What is cotangent cosine inverse of negative 2 over 3?
Like a triangle.
You have to draw a triangle. I'm going to show you how to do it first. So this represents a data, right? Because cosine inverse is going to give you a data. So this means there is a triangle, but you have to base on a quadrant. Now cosine inverse is the top 2 quadrant because the inverse is in the top 2 quadrant. Now cosine inverse is negative is this quadrant. So you're going to draw a reference triangle here and make sure you draw a reference triangle in that specific way. Now, also make sure that 3 is always positive because hypotenuse is always positive, never negative. Hypotenuse cannot be negative. Now, this side is negative 2 because it's on the left side, so x has to be negative. You can figure out this side. We're going to call this side y. So negative 2 squared plus y squared is equal to 3 squared. So y squared is equal to 5. Y equal to square root of 5. So this is equal to square root of 5. Is that okay? Now, since this is a cotangent of a theta, because this represents a theta, so therefore is going to be cotangent theta is equal to adjacent over opposite. So be adjacent is going to be negative 2 over square root of 5. You can rationalize this. Now you can try one here. Try these questions. Try E. Oh, the second E.
Second one.
The one on the circle one.
Is it triangle?
How much time I have? What time you get off here?
Yeah.
1
1 minute?
Yeah.
You probably got it wrong again.
Huh?
I said you probably got it wrong again.
I'm gonna do that. Which one?
Yes.
You need the second. Oh. I'm not.
Separate you just you don't have the clutch in.
Bro, I do. I was laying the BC on. So I'll just say negative.
You're not clutch.
Opposite over.
You got it?
I got all that over Jason.
Okay, what's your answer, Jacob?
It's so
Negative square root 10.
Is that? I don't think so.
Yeah, you go. Oh, Wednesday, though.
Who got what? Work it. Liam, did you get answer?
I got
No? Emily?
I got negative square root of 10 over 10.
Screw 10 over 10? I don't know.
It's not.
This will be on the test.
Three square root is 8/8.
So 10 inverse is on this quadrant. Is that okay?
10 inverse.
And it's going to be on this quadrant because it's negative. So which one need to be -3? The x or y? You have to decide. By visually, you can see that x is a positive, right? Y is negative. Does that make sense? And then this is going to be square root 10. Okay. So cosecant of theta is equal to 1 over y, right? Is that okay? Wait, it's 1 over y or y? Oh, hold on a second. Secant theta is what? The hypotenuse. So hypotenuse over opposite, right? So what's hypotenuse?
Square root of 10.
Square root 10. What's opposite? -3. Is that right? That's what you get? Miranda, did you get? Negative square root of 10 over 3. Wait, hold on a second. Hold on a second. Hold on a second. Oh, I got this wrong. Sorry. This is 1 over -3. Sorry.
It is. Wait.
This is no, sorry. This is the -1. So my fault.
So,
So that's equal to what?
okay, it's 1.
Square root of 10 over -1. So it'll be negative square root of 10.
Wait, why does it take one go?
Because it's y over x.
No, that makes sense.
So negative square root of 10. You got positive square root of 10, right?
No, I said negative square root of 10 over 3.
Okay, good. You're better than me.
I have the answers from last time, but I thought you did.
Can I go grab lunch?
Yeah.
Yeah.
If I wanted to be limited to sign it, did I have that?
I didn't ask that.
Yes, I actually I know.
Come on, this one, bro. You're not saying anything right. If you miss one or two, that's really see all of them, bro.
Let me see.
like 3:30.
Yo, that's like it.
Come along.
I'll get here. I'll take
But you gotta not eat lunch. You come here, you did not do work yesterday.
Oh, I see. 30 minutes.
So I want to hear right.
Are you talking Michelle last year?
No, I'm going right. I didn't see like my sister.
Yeah, your test grade is not good, I think. I think only something I heard.
So
What's up?
the homework, all of it?
All the way to 5. I mean, if you know how to do 5.
Oh, all the way to 5, like
Yeah.
all of those.
Yeah.
Wait, but why is the 1 negative? I don't get it.
Because it's below x-axis, so y has to be negative.
Well, I had 1 here and 3 here negative.
Yeah, I did it wrong too because it's y over x. Tangent is y over x.
So what happens if it's like sine or cosine?
Sine is gonna be y over hypotenuse.
What?
No, sine is.
Sine's the opposite of hypotenuse.
Oh, so you have to. Oh, you have to think of that. Perfect. Thank you.
Open it faster. You're gonna have to come back later because I have the next period I have to prepare. So after
Do you want to come back for lunch or
you can if you want.
after school?
Huh?
After school.
You need to come after school because you did bad on the test.
Um,
I don't know how bad it is, but I know it's not good.
I'll be honest, I'm really lost like on this section. Is there anything that I can do online or like look at like videos or anything?
Yeah, that's